Hello and welcome. Okay, so this is just going over the algebra of limits. So it's really straightforward. I'm just going to jump right in. Basically, and oh, by the way, assume f and g are continuous. Okay, anytime that there's a discontinuity, you need to investigate it. Okay, and again, we do that by examining the left hand limit and the right hand limit, um, and seeing what their values are. But anyway, as long as they're continuous, you can do this. So if we have the limit as x approaches some number of f plus g, where these are any two functions, any two continuous functions, you can calculate the limits separately. And that really is the theme of this video. So you can do the f part, find the limit, do the g part, find the limit, and then add them together. Okay, if you have the limit of a product, then guess what? You can do the product of the limits. No surprise, okay? If we have the limit of a quotient as long as the denominator is not 0, because that would violate our condition of continuity, then we can do the quotient of the limits. Okay. Not a surprise. Okay. The other one that might be kind of weird, and I will do an example for this one, is the limit of a composition. Right? So if I have the limit as x approaches a f of g of x, you may see it written this way. You may see it written this way. F little dot g, that's f composed g. Then what you can do is this: you can find the limit of the g part first. Okay, you can find the limit. In other words, you can take the limit inside f, find the limit of the g part, and then whatever that number is, just do f of that number. As long as f and g are continuous, you can do this. Okay. I want to do just a simple example to illustrate this. I don't want to be too crazy about it. Let's say, for example, and let's see, I'm going to change my color. Change the color. Oops. Let's say f is something like x squared minus 5x. Let's say g of x is 3x plus 7. Okay. Now, this is probably going to take a little bit of time, but I want you to understand what I'm talking about, okay? Let's say we want the limit as x approaches 2 of the composition. Okay? Well, if we didn't have this limit theorem, then first we'd have to figure out what the composition is. Let's go ahead and do that. F of g of x. So we're going to take the function g and put it in the input, the x on f. Okay? So in other words, x squared, except instead of x, it's going to be 3x plus 7. So I get 3x plus 7 squared minus 5 times 3x plus 7. This is how I find the composition. Okay, and I gotta do some algebra. Okay, you know what? Yeah, I'll do I'll factor first. 3x plus 7, leaving 3x plus 7 minus 5. That's going to give me limit as x approaches 2. 3x plus 7 multiplied by, and then 7 minus 5 is 2, so 3x plus 2. Okay? Now, when I plug in the limit, when I plug in 2, I'm going to get 3 times 2 plus 7 in my first group, multiplied by 3 times 2 plus 2. Okay? And so if I do that, I get 6 plus 7. That's going to be 13. Multiplied by, let's see, 6 plus 2, right? 8. 13 times 8. That's like 80 plus 24. 104? That seems weird. 80 plus, yeah, 104. Okay, so that's how we'd have to do it, if we didn't have this limit rule. Now, let's do it with the limit rule. And so to sort of emphasize we're doing something different, I'm going to change my color. Yeah, right about there. Let's use this rule now. Okay, so f of limit x approaches 2 of g of x. Okay, well, g of x here is 3x plus 7. So this is going to be, let's see, f of, and now it's going to be, so plug in 2 to 3x plus 7, 3 times 2 plus 7. F of 3 times 2 plus 7. I'll make sure I didn't mess that up. Yeah. That's going to be f of, and then 3 times 2 is 6. 6 plus 7, 13. Yes. Okay. And now, let's see. Here's f. Okay, f of 13. That's going to be 13 squared minus 5 times 13. 13 squared, 13 times 13, that's 169, minus 5 times 13, that's going to be 65. And there we go, right? 169 minus 65, 104. And see how much less computation that took. Okay, so that is, sort of illustrating this limit of a continuous function property. Okay, and that's exactly what this is called. This is let's do this. Let's call it. Let's be very careful here. This is the limit of a continuous composition of functions. Woo! Okay. And what I want you guys to do is I want you, for starters, what I want you to do, if you're learning this in any capacity, is repeat what I did for g of f of x. Okay, so in other words, go through this calculation where you actually calculate the composition, get the limit that way, and then repeat the process using this limit of a continuous composition theorem, and see if you get the same result. Okay, so there we go.